Yeah.
Hello everyone. Good afternoon.
Good afternoon, sir.
Good afternoon. So nice to see you guys again after almost half a year. I think most of you were there in the SY, right?
Yes, sir.
SY physics.
Yes, sir.
Okay.
I think only 2 or 3 are there who are not. Rest all are SYs.
Okay. So how many of you know Python?
Sir, please ask the other way around.
How many of you don't know Python? Yeah, that is. Yeah, you were saying something. 094. Yeah.
I don't know the Python.
You don't know the Python at all.
Yes, sir.
Okay. What about others?
Sir, roughly whatever you taught last year.
So you remember that, right?
Yes, most of all, yes.
Yes, sir. I remember some of that.
Not everything, but yes.
Yeah, once you start programming again, then it's just because you are not in touch. That's why you might feel like not remembering the course, but it's okay. Means if you know the Python up to an extent, you can easily recall. Recalling is very easy. Okay. 094 Avishkar. No? Avishkar, yeah.
Yes, sir.
Can you tell me your background about programming?
So what?
But your programming background.
So in SY BSc, I was having the physics and geo combination.
So you physics geo, na? So you must be knowing
Chemistry and geo. Sorry.
Chem geo. Okay.
Yes,
So
sir.
what you know about programming?
So I'm completely unaware of it because I haven't encountered it previously.
Okay, because we need some background of Python, at least basic background. Leena, madam.
Yes, sir.
Madam, this student don't have a background of Python at all or programming at all. So
It's okay, sir. I don't think there will be any issue. And even, I mean, other students can help him. It's no issue.
So I'll try to keep things as if I'm teaching first time, that you guys don't know much of the thing. The part I'm going to do is the first part you guys already have done in your practicals, but I'll try to teach it as if it is done first time. Okay. So Avishkar, if you don't follow right now, okay, so I will put some basic part. Okay. And if you still don't follow, we can discuss later on in more detail separately.
Okay, sir. Thank you.
Okay, so let's start. So what we are going to do is that we are going to do Python programming, but what this time we'll do it in the Colab. The reason being is that we need some commands, and looking at the variety of devices everyone is having, some people are having Mac, some people are having Windows, some are using their mobile phone. So looking at the variety of instruments, we decided that we'll go for something which has to be a common thing to everyone. So we decided we'll go for a common and easily available to everyone. So that we decided that we'll go for a Colab because it's a product of Google. So if you have a Google account, which we all have, we can easily go and write the programs in Colab. So what you have to do is that type in Colab in your Google bar, search bar, and Colab you'll open. It will ask for a login if you are not logged in. If your Gmail login is not activated that time, so it will ask for a login. Once you log in through Gmail, the Colab will save the files just like Google Forms or Google Sheets or Google Word in your drive directly, and those files are shareable with anyone else. So you have to just share the file with anyone. You have to just send the link of that Colab file. So when we will interact, when you are going to send us experiment, you can send the link instead of downloading the file and installing the file, sorry, uploading the file. You can just share the link. These are shareable files directly on the net. Okay, let me share show you share the screen. Okay, can you see a screen where it is written untitled 7.ipynb? Okay, so this is right now I already kept a Colab file open. Now, as you can see, it is open in the Explorer or internet browser. Okay, it got commands, file, all those things, internet, runtime tools, so which are just like what we need for the programming part. And you can say there is a infinity symbol, which is a symbol for Colab. Now below that there is a plus sign, plus code, and plus text. So what you can do is that in the Colab, we have done the most of the programming in Spider. That's why I'm explaining this part. The codes will remain the same. Codes in Spider, code in Colab, codes in Jupyter Notebook, everywhere the code will remain the same. Some parts slightly will change, some more very specific part. But rest of the code will, I think it will remain 100% same, not 99, 100% same. So here what happens is that you can add cell. So there is a cell. So when you open this Colab file, you have to go to the file and say new note. Once you click that, or you can, if you already have a notebook, you can say open note. Okay. Once you open the notebook, you will get a cell like this, which has a run symbol on the left hand side. Now this is a cell, a executable cell. Okay. Now you can add two type of cells. You can add a code cell or you can add a text cell. So text cell is something which is not executable, but you can type any information related to this program. So let's say that I add here one text file and I can move up. So it goes here. So I can double click on this and I can start type. So this is the intro. DL. Okay, so I have typed, this is the introduction to DL. Okay, if I click outside on the next cell, this cell will get deactivated. Now the second cell is activated. Now this second cell is I have added using the plus code. Okay, when you are in the cell, you can see there are symbols here. Top arrow, upward arrow, downward arrow. Then there is a link to the cell. Then there is a add a comment. Then there is a settings for this particular cell, and you can delete the cell or you can copy the cell. Okay, so you can do many things with this cell. Okay, so I can click in the cell. Now this is for the code. So here the browser is expecting, or Colab is expecting, that you will type a code here. So let's type a simple code. Okay, and I'll just run this one so that you are very well introduced with the Colab, and then we'll go for the actual code. So let me write x is equal to 45 and y is equal to 56. So x and y are basically a memory locations created somewhere in the server. Just like Spider creates in computer hard disk, here it is created somewhere in the server, and the values 45 and 56 are stored in there. Now we can say that print x plus y. Okay, and now this is a 3-line code. If you want to run that, you have to just press a run button on that particular cell. If I press run button, the cell will run. Now to work with the Colab, you need to be connected to the internet. Without internet, you won't be able to work with the Colab. Now it says 101. This is the right answer. So you get an answer below that. Is it clear, this part? Hello?
Yes.
Yes, sir.
Okay. So you got the idea now how the actual code can run. Now what we can do is that we can add one more code cell, basically coding cell. So I added one more coding cell. Here I can say that z is equal to say 100, and now I can use the data from the previous cell. So I can say that say print x plus z. So I'm using x from the previous cell to add up with the variable which is in this current cell. If I run this one, then I'll get a program 145. But to computer or Colab to understand there is a variable called x, the previous cell has to be first executed. So you have to execute the previous cell which has a x value, x variable basically, and then you can run the next cell which going to use the x value, x variable. Okay, if you try to run this cell directly instead of running the previous cell, then it will show you error because x is still not created. Okay, so you have to run the previous cell first, where the second cell is based on the previous. So it is interdependent. So first previous cell has to be executed, then the second cell. Okay, this is clear.
Yes, sir.
Okay. And the mathematical other operations which are multiplication, division, floor division, then modulo operator, all those things you guys know. So I won't explain to the majority of you. So for the students who are not acquainted with the Python, we can have a small discussion later on separately where I can give you a basic idea about the Python, and then you can work with that later on. But I will avoid going for those discussions here. Okay. So what we'll do, we'll directly go to the part where which we'll need in the end. So I'm just deleting this part. We delete this cell also, second cell. So I deleted the second cell, third cell basically. First cell is a text file. Now what we are going to do is that for a DIP we need arrays. So when you say a image, what is the image? Can anyone tell me when you look at the image? A general image. Suppose you got an image, a black and white image. What is that? Hello.
Matrices of pixels.
Yeah. So it's basically a matrices of small boxes of specific colors. So those boxes are called as pixels. And computer, when it stores this image, it stores a value related to that particular color combination or a intensity of that particular thing. So computer stores in the form of some XY plot where each point has a value, which we can call as a matrix. So to work with the matrix, let's get introduced with the matrix. What is a matrix? Matrix is nothing but a kind of an array. Okay, but matrix can be a part of array, but array is much bigger than that. Okay, so when you do operations with the array, you have to remember that it's the array you are operating with, not the matrix. So some operations which are with the matrix will not work with the array. It will be different answer. So you have to tell the computer that I am going to use this array as a matrix. That you have to specify to the computer. Okay, so that also I'll show you. So let's try to create an array. So let's say I got value a. So for array, what I'm going to do is that I'm going to use a module called as Numpy. So let me first import that module. So I'll write import. We have done this in SY, most of the thing, and Numpy as NP. The word NP is used everywhere, so I'm using. Otherwise, you can label it with anything else. That is also. Okay, so I'm going to import the Numpy module. Done. Let me go to the next cell itself. So this is I'm going to execute, and I'll take one more cell. Here I'll write, say, a variable a, which I am going to create an array. So array is like a train of variables. Instead of a single variable, it's variables created next to each other physically. Means in the memory locations, the memory variables are created next to each other. If first variable is at the position 100, the next variable will be at the position 101. Third will be on 102, like that. So let me write NP means now we are going to call Numpy as NP. So we are going to say NP dot array. So use a program called as array from the NP module, which we already imported. So NP module, Numpy is a module which contains lot of programs. Okay, so each program is for a specific purpose. Instead of writing those programs from the scratch, what we are going to do is that we are going to just import the Numpy. So once Numpy is with us, we can take programs from the Numpy. So we have to specify which program we want to use. So when you say np.array, what we are saying is that we want to use array program from Numpy. Now what is the job of this array program? The array program will create a array. To do that, we have to put a single bracket, and then we have to put a square bracket. Now, can anyone tell me what kind of data type we put it in the square bracket? basic data type. They're done in the last year. List, tuple, directory.
Integers, float.
List. Yeah, right. So when you put it in the square bracket, it's a list. So what we are going to do is that we are going to provide a list to the array program called as array, which is in the Numpy. And what output we'll get is basically a array created out of that list. Okay. So let me write here 1, 2, 3, 4. So I'm giving a list of 4 size, right? Which is having the elements 1, 2, 3, 4. Done. So now if I run this part, I'll get a A as an array. So let me add one more code line here. I'll say print this array A. So A is no more a list, it's an array. It is, so I have to run this one. So I get a array with a square bracket 1, 2, 4. That is clear? Hello. Hello.
Yes, sir.
Yeah. Now, if you want, you can. This is one-dimensional array. If you want, you can create a two-dimensional array also. So let me create a two-dimensional array. I can add one more here. So basically, two-dimensional array is basically an array of array. So I can write 11, 12, 13, 14. Okay. Now this is an array of array. So I have to add one more bracket. So it's a list of list. So there are two lists which are elements in the a bigger list. Okay. Now let me run this code. Done. And now if I say print A, you can see it is a two-dimensional array. So there are two arrays in an array. That is clear. Same way you can create a three-dimensional array. You can say one more, right? And do that. Is it clear? Hello. You can keep
Yes.
on adding dimensions to an array. Now here what I did was that I created array using a manual insertion. So let me show you a few more things. Now this is, now if I run this C, I have changed the A, but this print A is still showing me the previous one because this cell, previous cell, A wala cell, I have not executed at all. So right now, even if I execute the last command, print A, it will still consider the value of A as the previous one, even though I have changed the command for A. So I have to run this one first. And okay,
Sir, what will happen if there is no square bracket?
no, if there is no square bracket, then the input will be invalid. This particular array function, which is a small program, needs a list as an input, and then it will give you an array.
So a small bracket is for what then?
Which one? The regular bracket.
Yes.
Regular bracket is to show that there is an input.
Okay.
So this is the input. So it says that whatever comes inside this bracket is the input. So what is the input? Input is a list. So let's come with a square bracket. And now we have to give the elements of the list. That is okay, Lina madam?
Yes, yes. Thank you.
Now, as I have executed the third cell, I can execute my fourth cell. And still it is 4. So let me execute the third cell first again. And then I execute the last cell, and then I get an updated thing. So always remember, when you execute these cells, they are dependent, or if they are dependent on the previous one, you have to execute the previous one and then the second one. So you have to always remember this, because what happens that we make 10 cells in our program, then we make changes somewhere in the middle because the output is not the way we want, and then we run only the last one, and still we are getting the same result, and then we get frustrated why the change is not getting reflected, because it is still in the form of just characters. You have to run that characters in some, create a program out of that, and then the result will change accordingly. Okay, so I think I am clear. Okay, so this is I have created an array. I can create an array. This is created array manually, means I am inserting a elements manually. So I typed 1, 2, 3, 4, like that. What I can do is that I can just type it in, different formats. So I can say np.arrange, and then I can say 1, 2. Okay, and now let's see what happens. And okay, so can you see just one has printed? So let me go here. Let's say 6. Can anyone tell me what happened here? You guys, the physics student must be knowing the function arrange. Right now I'm using as a part of Numpy, but we have used the arrange function for a core Python. So what has happened here? Hello.
It creates a list from 1 to 6 minus 1.
So it goes from 1 to 6, excluding 6. So 6 is not included because I'm not providing the spacing part. The spacing is considered by default 1, but I can provide a spacing also. So I can say spacing is 2. So it will go from 1 to 3, 3 to 5, and then 5 to 7 it should go, but it has to stop at 6. So 7 will not be included. So let me run again this one and this one again. I get 1, 3, 5. Okay. So we can create arrays like this. Now here I am not typing all the elements. I am just giving first character, first starting point, last end point, which is not included, and the spacing here. Okay, so I can do that also. There is one more way which we have done in the practicals called as np.linspace. Now linspace is used where similar type of thing. Here we were knowing the spacing. Now linspace can be used somewhere like this. So if I want to go from 1 to 6, but total elements I want is 10, then it is useful to create a linspace. In the previous case, the arrange one, we were more talking about the spacing part. So when my focus is on the spacing between the elements, then I can go for a arrange. But if my more focus is on the number of elements, then I can go for a linspace. And now if I run this one, I can see linspace is slightly more separate differently. It starts from 1, but it also includes 6, but total number of divisions are 10. Is it clear this part? Hello. Hello.
Yes, sir.
Okay. So let me go for np arrange again. Let me take 1, 6. Okay, so that I'll do some operations here. Now let me take one more. Let me take b. B is equal to np.arrange, and let me go it from 11 to 16, or let me go from 6 only, so that we get a square. And now I got 2 elements which are a and b, which are actually same. Take later. One second. So yeah, now what we can do is that we can write here c is equal to a plus b, and then we can print c. I'll execute the first cell, second cell, and I get an answer as addition of both the cells, but element by element. So first element is 1, so 1 is added together. Second element is 2, so 2 added with the b, it gets 4, like that. Element by element is printed on this. As they are arrays, they are considered the set of elements. So if I multiply this one, what I'm supposed to get? Can anyone tell me what I'll get here? Hello. Printing A, B, everyone. You can see here the output is basically multiplication of A and B, but element by element. Okay, so every elements are multiplied with each other. Is this clear? Hello.
Yes, sir.
Okay. Yeah. Then okay. I forgot to show you one more thing. I can say print. I can access a specific element just by typing the name of the array, say A, and if I want to go for a first element, I should write 0. And if I say run, what I'll get is the first element of array A, which is 1. If I type say 2, then I should get a third element, right? Okay. So you can change also. You can say is 2, which is a third element, is equal to 45, and I run this one. And if I say print A, I can get out. If I can get, I change one element in the array. So this is basic array things. I'll just show you one more thing. Then we are done with the arrays. Then I'll go ahead. We are done this one. So I can write C is equal to np dot sine, and then I can put an array here. So now what this is going to do is that it is going to take, this is going to take each element from A, take a sign of that, and create a new array C. So I forgot to print A. Sorry, my bad. It should be print C. This is clear. So I'm getting a new array C, which is nothing but sign of array A. So every element we have taken a sign and stored in C. This is clear. Same way you can use all other modules, all other functions from the Numpy. Log 10, log 2, log E, see, only log, sine, cos, all other functions which are available in Numpy, you can directly use for arrays. Is this part is clear to everyone?
Yes, sir.
Okay, so now we'll go to the actual DRP. So now we are going to work with the images, but basically we'll start with matrices, and then we'll create. Now what today we are going to learn from in the DRP practical is that the first part was introduction to arrays, because we will need arrays for creating images or extracting arrays from the images. So this was a basic. There are much more in the Numpy arrays. There are many things which I am not teaching right now, but you can go ahead on the internet and search for those things. But search as per your requirement, because there are so many things to learn. So now what I'll do, I'll just directly go to DRP. So I'll include some more modules for our purpose. So first one is from PIL, import image. So I'm taking PIL, which is basically a Python image library. So PIL is a library just like Numpy, which is a Python image library, which is used for image processing capabilities. So it enhances the Python programming by giving image processing capabilities to the Python. In that, we are going to take a submode called as image. Okay, so we're going to import image. Numpy anyway we want. Then we'll need a matplotlib. So I'll say import dot pyplot. I think we may not do this as Okay, let me keep it here. Okay, this is okay. Now we'll add a few more things. Let me add in the next cell itself. So I'll say import CV2. Again, this is also a module which we will need for image processing. So this module is for doing the manipulation with the images. Okay, and we'll add one more patch here. Now, if you work with any other software, any other interactive portal, then you might have to change this particular thing because this is specifically for the Colab from google.colab.patches import CV2 underscore ensure. This is also used for our image processing part. I'm running first module. I'm running the second module. Okay. So these two modules are run. So these are basically just loading our required modules, nothing else. Now we are going to add one more thing which will allow the Colab to store the file in the drive, because Colab cannot directly go and store the file in the Google Drive. So we have to tell the computer that go and store the values in the Google Drive. So let me go here and type from. So it will need one more module called as google.colab import drive. That is okay. So I am from the google.colab, which is a module itself. I'm going to include a sub module called as drive, and there I'll say drive dot mount means now connect to the drive. So for that I'll just here content slash. So what this is going to do is that this is going to connect our drive, our Colab to the drive, so you can store the images or read the images from the drive directly. So it will ask for go to this URL in a browser, and it will ask for authorization code. So what you have to do is that you have to click this one in the browser. So new image, new window will open, new tab will open basically, and then it will ask for which account you want to use. I'm using my account. Sign in. Okay. Then once you do sign in, it will tell you that please copy this code and switch to your application and paste it there. So this is like a communication from the drive to the Colab. I'm copying this one and pasting it here. Pressing enter. Now the cell will still running, and then finally it will say mounted at content slash drive. So now we have connected our Colab to this particular notebook to the drive. Is it clear?
Yes, sir.
Yes, sir.
This you have to do individually for each notebook. Huh? If you open a new notebook, this is basically you can just copy paste from afterwards. I will provide this code to you. You can just copy paste this one. Okay, because this is which is first three cells are basically common. So I'll share this first three cells directly with you. So every time whenever you start, is just take these three cells as it is, paste them, and then start with your. Okay. So now we'll start with our actual one. So what I will do, I'll add one more cell now. Now we'll start the work. So let me say A is equal to small a equal to np dot linspace. Okay, now we have learned what is linspace already. So we'll take say 0 to 10, comma, we want just 5. Okay, done. Now next thing I'm going to type, but I'm not going to tell you what is that. I will run the program and then you let me know what is it. So I'll write B is equal to np dot matrix. So this is like telling the numpy that now whatever I'm going to write should be considered as a matrix. And what I want to consider as a matrix, I want the array A should be considered as a matrix. Dot capital. So capital T is a part of the code. It is not a variable. Okay. Now let me print here. Print A and print B. Let's see what we get from the print A and print B. Can anyone tell me what happened?
You created a transpose of images, a matrix.
Okay, good. So I just the second line, which was B is equal to np dot matrix A, is basically telling take A as a matrix. Okay, and then do a transpose. So dot T was basically telling the np dot matrix function that do a transpose. Okay, so transpose T dot T is already defined, so you don't have to worry about what will happen if the T is nowhere, it is different. It is a part of the code. Okay, done. Now what we'll do is that we'll try to create a simple matrix, two-dimensional matrix. So because we got A and B, B is basically now considered a matrix. So now what we are going to do is that we are just going to write C is equal to, I'll write B asterisk, sorry, small b asterisk A. Okay, so what will happen if I write B asterisk A? I am basically now, because B is considered a matrix right now, the multiplication of matrix with the array, again A will consider the array and then C will be a matrix. So if I do B multiplied by A, now if you see, if I print A here, print C, the C will be 5 by 5 matrix. That is okay? Hello?
Yes, sir.
Okay. So once we got C, now what we are going to do is that we got a, as we were talking about the image is nothing but some numbers arranged in XY form, nothing else. They are like, if you take a colored image, basically there are 3 images overlapping on each other. Okay, RGB color images overlapping on each other. If you take a black and white image, it's just the gray color value is kept at different XY positions. So now let's consider this as a gray colored image. So we got a values. So on left hand side edge, we got value 0. On the top edge, we got value 0. And at the bottom part, we got, at the corner, we got 100, which is the maximum. So now what we'll do is that we'll convert this two-dimensional matrix or two-dimensional array in a image. For that, we're going to use CV to underscore imshow. And we are just going to do CV underscore imshow is a function which will convert a matrix or a two-dimensional array to an image. So we have to provide an input. So input is C. I press this one. Now you can see there is a small dot type of thing. Can you see here at the end? Basically that is the image, but it is 5 by 5. So it is 5 pixels by 5 pixels. That's why it is small. So let's increase the size, but then size of this printing of this 3 matrix will increase. So let me take out this printing of this matrix. So hash. Now I want print matrix ABC. I'll directly print the image because we know what is how the matrix ABC looks like, or the array ABC looks like. So now let me take this is as 100. So I will be making a C as 100 by 100, and then I'll convert to a image. Can you see now? Let's look at the top edge and left edge. It is totally black. Look at the right hand side bottom part, which is slightly lighter color than the other part, right? Let me take this one as 0 to 100. So let me take this one as 100. Oh, okay. So let 16. This is okay. Can you see the there is a gray colored gradient along the diagonal? Okay. So bottom right corner is the white, completely white. Top left corner is completely dark. Okay. So upper edge completely dark, left edge completely dark, and color goes down. Color goes become gray and towards white as you grow along the diagonal. Is it clear? Hello.
Yes.
Okay, so now why I have taken 16 here? If you see the Linspace, I started from 0 and I have end up with 16 because the gray color is basically, what is the gray color? What is the end of gray colors? You will have completely white or you will have completely black, right? And all other shades are in between. Am I right? Hello.
Yes, sir.
Now they are divided into 256 levels from 0 to 256. So 0 to 255. So they are divided into 256 levels. So 0 level is basically completely black and 255 is completely white. Now, as we are going to create a n by n matrix, if you take a 0 to 16, then the in the matrix, the bottommost, the right hand side corner will be 256 because 16 multiplied by 16 is 256. So that will be the white element. If I go ahead beyond 16, then see what happens. Because the product goes above 255, all points above 255 is considered as completely white. That's why the saturation becomes very high. So if I 16, if I take 20, then some elements not at the corner also will become completely white. Run here, you can see that that whole patch has become white because those points are gone values about 255 and above. Okay, because I am taking now 0 to 20. So 20 square is 400, is about 255. Is it clear this part?
Yes, sir.
Okay, so this is one image. Now if you take 100 instead of 100, suppose you take say you take this is 16, let me put it 16, and I have taken 100, but let me take instead of 100, let me take 500. Now what should happen? I will get 500 by 500 matrix. The image size will increase. Okay, that is clear. You can see the image size. This is clear. Hello.
Yes.
Sir.
So up to this point, everything is clear.
Yes, sir.
Okay, I am almost done. Okay, now the last part. The image is there. Now let's try to store it. I'll write the code cv2 dot imwrite, write the image, and then bracket. So we have to just specify the path where you want to write, and the image. Image is basically our C. So let me write C here. And then I'll write a path. Let me type the path directly. So yeah, slash content slash drive. In that drive, we got a my drive because your drive will have multiple paths, shared and nothing. So in that my drive, and in that I got a folder called dip slash. I want to store the file say c.png. Okay, then I'll run this one. Okay, that is okay. Now, is it okay? Clear? Hello. Hello.
Yes, sir.
Yes, sir.
Okay, now I'll go to my drive and let me check. You can see my drive.
Yes, sir.
There is a folder which I already created, DIP. Let me click on the DIP folder. Now this is the file c.png. Is this clear? So now you can store the images directly. You can also read the images, no problem. Now we are done with the part. You can now, I'll just type one more code. You try out at your end. So let me add code here. I'll just add one more thing called as ones. I think we are already done. Let me write a is equal to np dot ones. Okay, and set 10. So you know what is ones, right? Can anyone tell me what is ones?
It creates a list of one. All elements will be one.
Right, good. So now I'll do np b is equal to np dot Linspace. All elements are basically one. Zeros, if you write, all elements will be zeros. 0, 99, 10. Okay. So basically, I'm taking b also as an element. That is also 10 element, and then I'm going to multiply this one. I'll write c is equal to what I should do now. b. So np dot matrix e dot t. Now that should be multiplied with a, and then we say cv. Okay, then I'll say cv2 underscore im show. I should create an image and show for what? For c. Now, what do you think? What kind of image will be created? Okay, so before we go for an image, let me say print c itself. Print c. Can anyone tell me now how the image will look like?
Horizontal
Ten bands of different gradient.
Not horizontal, vertical gradient.
Yeah, vertical gradient, horizontal bands.
Or horizontal bands. Yeah, you can change the direction of the gradient depending upon how you create C. So it is just manipulate A and B, multiply n by E to get a n by n matrix. The way you have A and B, the gradient direction of the gradient will change. Okay, so we are done with this part. Leena madam, are you there? Hello. Yeah, what Leena madam is going to do is that Leena madam is going to share activity with you guys, which are based on this, and some part I think you're done with the theory part. Some part also added from there also. So that activity you have to do and come back by 3 o'clock if any doubt.
Actually, sir, I have not uploaded. So I'll do. So by the time, let them practice these horizontal, vertical, diagonal gradient, how to save image. Even please try and crop a particular part of the image and display it. Okay, so let's say you have created a 100 cross 100 gradient image and you want to take, let's say, part of 1/4 image from right hand side top, left hand side bottom. So try all those things, and then after some time I'll be giving you the exercise. So the exercise that will be given to you has to be done individually. So you will do it in Colab, get the output and paste all the codes and the image output that you get in one Word file, convert it in the form of PDF. So you will be uploading one PDF for one experiment. So this was experiment 1. So all the exercise that you do should be clubbed only in one PDF. Okay.
Anything else I should explain, or this is good enough?
I think
Could you show us again how to save the image as PNG file in Drive? What was the code?
Take I'll share. The code was cv2.im, right?
Okay, sir. Thank you.
Yeah. Now there is one more code for uploading the image. Similarly, you can upload the image. Now that when you upload the image, you can upload in a array. Once you get uploaded in the array, now then there you can manipulate. That madam will teach you, and once you manipulate that, you can again store as an image. So image can be processed. So basically, what we are doing is that we are going to converting image to an array, manipulating there all mathematical operations, and then storing again as an image. So you can work, you can play with the image. So is im right. Similarly, there will be a command for loading the image that you can find out by yourself. Okay, I'll just give you these first 3 cells. Madam, is it okay if I give them first 3 cells?
Yes, fine.
Okay, so what
Because
I'll
that's
do?
a common thing that all of them will need. Maybe they can just keep a screenshot. I also shared with them earlier. So they have, I think.
Okay, if they have, then it's okay. Otherwise, I can just share these 3 cells directly. Just all other thing I'll keep blank.
Or they can just take a screenshot and copy.
Screenshot, huh?
That's also okay.
Okay. So please take a screenshot and then you can just type this one.
Rajesh sir is also here. Sir, do you want to add something? Is sir here? I thought he's there. No, I don't see him. So we should come back at 3.
Okay.
Okay. So come back to the same link 3. Please make sure that you practice all the commands. Try all kind of gradient. And the arithmetic operation that we saw in the morning, that also you have to do. So let's say you have created 2 separate images, add them, subtract them, and also create a code for the equation that I asked you to copy in the morning. Okay, for that auto scaling thing, remember? Correct? Yes, you follow or not?
Ma'am, the last instruction, could you just repeat?
I'm saying that on that IIT virtual lab that we saw for auto scaling, I asked you to copy that, equation, which will convert our output in the range of 0 to 255.
Yes, ma'am. Yes, ma'am.
Okay, so here when you will be doing addition, subtraction, so basically we will be again redoing the thing that we saw in that IITB virtual lab. But only difference will be you will be doing using the image that you will be generating yourself. Okay?
Okay, ma'am.
Okay, ma'am.
Okay. Okay, then see you all at 3 again. Bye. Sir, you can also stop recording.